Hello everyone. So the next topic from module 1 is on how operations on process, how operations of process is done, and interprocess communication. So first one is different operations of process include creation of process, termination of process, aborting a process and all. So we'll see first how to create a process and how it is terminated. So to create a child process, we use fork system call in Unix method. Parent process, like every parent process can create child process, and this structure creation of child process we represent in the form of T structure, and every process which is created will have a process identifier, process ID, a unique identification number, and resource sharing option is allowed from parent and child. Like parents resources can be shared by child process, and child shares subset of parents resources to next level of children's, and so on. Execution is like once a parent needs to complete execution, all his child has to be complete. Like if a parent needs to complete his execution, first all the children process should complete the execution, then a parent process can complete, and until the child process terminates, the parent process has to wait for execution. So this is how tree of process in Linux is represented. First process which will start when you start the Linux operating system is init process, and the process ID of init will be 1. If there is a login for one user, then the process ID is the random ID, but a specific ID given for that process, like that login, and he will start like a bash program, so that PID will be given, and so on. Then this is like user programs, user process, and this side we'll see all kernel process, kthread add, kthread creation program with the 2, and khelper which is of PID 2, and so on. And this is one more, we can consider this is one more user program, and the PID for each process is provided, and which is represented in the form of thread. Until the lower levels of process is terminated, the init program has to wait for its completion of execution. Next one is creation of process in Unix operating system. So children, whenever a process is created, address space of parent will be duplicated with child, and the program for the child program, child process, will be loaded again. So Unix operating system, we use fork system call for creation of new process, and exe system call for execution of that process. So fork system call is called from the parents, if there is a parent process, if it calls fork, then a process child process will be created, and once a child process is created, parent process will go to wait state, but the child process what it is created with the help of fork system call will execute and exit until the child system call, child process exits the function or exits the execution. Then the process, a parent process, will resume its execution. So with the help of fork, a child process is created, and child process will start execution. Once it starts execution, parent process will go to wait state until child program is exit or child process completes its execution. Once child process completes its execution, parent process will resume its execution. Next one is termination. Exit system call is used to terminate a process. So program execution last statement, and then ask the operating system to delete its execution using exit system call. If a process need to wait for something, then wait system call is used. If a parent process need to suspend a children process, child process, then it uses abort system call. So any child which is created by a process can be aborted from the parent system call, and if there are many conditions to do so, like if a child has executed the allocated resources, like it has exceeding the resources what it was allocated for it, then we can abort it, like parent process can abort it. And task assigned for that child process is taking very longer time, it is not even completing it, then we can abort the process, and so on. Next one is process termination, means continuation of process termination. So we have like cascading termination, all children, grandchildren, all like init process can forcefully stop all its child process execution, called cascading termination, stop all the process. And whenever a parent process is in wait for terminating the user, like a child process, the system called wait is used for the parent process to wait for the children process. And whenever it returns, like wait process will return the status, it returns with process ID. So the parent process will come to know what process, like which children process is making the parent process is under wait state. If no parent if no parent is waiting for a children, then we call it as zombie. Like a children process is created, but there is no parent process waiting for a child process to complete, so that type of process we call it as zombie process. And operating system is responsible for terminating that kinds of zombie process. If parent terminated without invoking wait, the process is an orphan. So parent will create a child process, but parent is not waiting for the child process to execute in the form of wait, then the process is called as orphan. This zombie and orphan processes are handled by operating system to terminate them. Next one is interprocess communication. So we have independent process and cooperating processes. Independent process is very simple, it will come, executes its process, and it will terminate. No other process is dependent on it, and this process is not dependent on any other process. But if it is cooperating process, then the data, like a process is dependent on some other process for some data, or this process data will be used by some other process. So there is a form of communication to share the data between this process. Like reason may be like information sharing, computational speed up, it may be modularity and convenience. So inter-process communication is supported by operating system for sharing memory and passing messages. Two models of inter-process communication are sharing memory and message passing. So this is how communication of process happens. This is like for message passing and shared memory. In the kernel, like in the main memory, a part is given for a part is given for operating system called kernel, and other part we use for user process. So there will be a message queue in message passing system. Main memory will have one block of message queue and the messages stored with the address to which process ID that message has to be sent. So each and every process is accessing this message queue if there is a message with respect to that process ID. So if at all M0 has to be sent for process ID A, then the process A can take the message. Based on the message queue, the process will take the message. Next one is shared memory. So in this, there is no mean of transferring the message. Like instead, if there are two processes using communication model for data exchange, then a shared memory is allocated for the process which is under communication. This shared memory will have the data which has to be shared by process A and process B, which is not accessed by some other process which is not in this shared memory accessibility. This is how message passing and shared memory method is used. Next one is cooperating process. So cooperating process is a process where two processes, like if you take process A and process B, they are sharing a data. So one process is affected by the data of other process, so we call that type of process as cooperating process. Or we can tell interprocess communication are used by the process, we call it as cooperative process. If the process is independent, it is not using any information from any other process, then we call it as independent process. Next one is buffering. So every process which is sharing the data or which is sharing a message from one process to another process uses a buffer, means a short term memory system which can be used for copying the data. Or we can tell buffering is a queue of messages which is attached to a link. There are three types of buffering. One is zero capacity buffer, means there is no message queue from sender to receiver. Second one is bounded capacity. So there is a finite length, like size of length allocated. So if it is having n size of a message, then sender can fill that n. Then a waiter, like a consumer has to wait, or a receiver has to wait until that bounded buffer is filled. Next one is unbounded. So sender has no limit for sending, like there is no limit of message size. So sender can send infinite length of the message for the receiver. So next one is producer consumer problem. So producer consumer problem we used to explain, means this problem is used to explain using a buffer, like unbounded and bounded buffer, both the buffers, how a producer can produce the data and the consumer will be consuming it. If it is unbounded buffer, then a producer need not to wait for the consumer to consume the data because it is unbounded, like the size of the buffer is not restricted. So producer will keep on producing the data and consumer will consume. Problem with bounded buffer, because there will be fixed size of buffer, like buffer size will be fixed. So if the producer start producing the data more than the size of the buffer, then data will be lost. If the consumer is consuming the data without the producer's knowledge, then consumer may not get proper data from the producer. So to solve this, we'll see how using bounded buffer problem, producer and consumer problem is solved. So main concept of producer and consumer problem with bounded buffer is, until producer produces the data of specified size, consumer has to wait. Once consumer starts consuming the data, till consuming complete data which producer has produced first, producer has to wait. So this is how producer consumer method is solved, producer consumer problem is solved for bounded buffer. So first one is we'll create a buffer with the size of 10. So buffer size is defined as 10, and structure there is a structure created with different types of variables, and for this structure an array of buffer is created with the buffer size. So 10 is the size of the buffer, means bounded buffer limit we have fixed it for 10. There are two pointers, in and out. In pointer is used to write the data to the buffer. Out pointer is used for reading the data from the buffer. So the solution is, if it is producer, while true for the producer, then producer has to wait until the consumer has consumed the data. So the condition here is very simple. In plus 1 means in pointer plus 1 modulus of buffer size, which is equal to out. If modulus of in plus 1 buffer size is equal to 1, it states that the consumer is consuming the data, so producer has to do nothing unless it is under infinite loop. It will be under loop but doing nothing. If at all this condition is false, then buffer in is equal to next produced. So to the in pointer, next produced data will be added. In is equal to in plus 1 buffer size. In pointer will be upgraded. Next, once you come to consumer problem, the same method, consumer has to wait until producer is producing the data. So while true for the consumer, while in equal to out, means in pointer is equal to out, then what we'll do, if the value of in and out are equal, do nothing. It means producer is still producing the data, consumer has to wait. If in pointer is not equal to consumer, like out pointer, then next consumer is equal to buffer out. So the data from the buffer out pointer can be consumed next. Then out pointer will be upgraded, out equal to out plus 1% of buffer size. So consumer has consumed the data, producer was waiting. When producer was producing the data, consumer was waiting. So this is how producer consumer problem for bounded buffer is solved. I hope you understood the topic. Thank you.